Thermodynamics is a pretty neat thing, but when you cross it over with astrophysics, you get a highly exothermic product. There are a set of laws laid down regarding thermodynamics. We will be discussing the sickest of them all, the second law of thermodynamics, which goes something like this. The entropy of the universe is always increasing. Let's understand about entropy first. Entropy is basically the degree of randomness and/or disorder. If entropy is said to increase, then it is getting more out of order, that is, randomizing itself. There is a simple example for this. A block of naphthalene is in a chemical flask. After a few moments, you can see that the block is still there, idle and inert. Now let's apply heat to the flask. As most of you might know, naphthalene is sublimable, hence it converts directly into vapor. Now the naphthalene is in a gaseous state. If one records the exact position of all the gaseous particles at once, after some time there is even remotely no chance the particles will still be there. The particles will move around and will eventually escape the open flask and mix with the air, where they will scatter so widely that you just can't locate the particles. That is basically what is called entropy. The solid state had no entropy whatsoever, but when it was converted into a gas, the entropy was significant and visible. Let's know what makes entropy such a big deal. There are two driving factors for chemical reactions: minimizing energy and maximizing entropy. All real/spontaneous reactions try to achieve minimum energy and maximum entropy. Lesser the energy, more the stability. And it is visible in our daily life. And so substances try to lose energy. Just like that, substances or reactions try to be more chaotic. In a nutshell, it means this. Everything reacts to increase its disorderness. It wants to spread, move, expand, extend the interactions. That is the likely thing, and it always tries to follow that. There is a hot object and a cold object side by side. Naturally, the hot object spreads heat so that both attain a perfect similar temperature. Here both factors are at work. The hot object wants to lose energy to be more stable, so it readily gives out the heat. But that also applies for the cold object. It also doesn't want to gain heat, but it does. Why? Entropy. The heat is wanting to spread, and it does. That is nature. It can apply to anything, even as humans. What if everybody in the world just perpetually freezes for eternity? Imagine we have sufficient survival supplies, we all become isolated and just stay to ourselves. You can admit it sounds implausible. We can't restrain ourselves. Everybody tends to move, spread, socialize, and of course, interact.